Hi there, in this lecture I'm going to describe how in PySpace you can relate two very well-known formulas to figure out how to calculate things like orbits and positions. Um, these are well-known formulas, so let's get started. In previous lectures I explained that the Pythagorean theorem was in PySpace was seen as nothing more than a way in which you can add together the two areas of a sphere, and you get the third area of a sphere, or you can get a larger sphere, subtract an area, and you can get a larger area, subtract a sphere, and get another one. Now the thing about the Pythagorean theorem is it's always at right angles, and in reality, as we all know, you may not get two spheres at right angles to one another. So what do you do in that situation? And the answer is that you use the law of the cosines, and it's very well known. And the law of the cosines is the following: that the distance traveled is squared is equal to a squared plus b squared times 2ab cos theta. Okay, so here's a diagram of that idea. So what mapping this to PySpace, you can think of an atom moving in a particular direction on the A vertex, and another atom moving in the B vertex, and basically you've got a C vertex, and you can add them together to get the resulting distance. So you can use the law of the cosines to add A and B together, and each pi shell is seen as a per second pi shell. Okay, so later I'll show how we can apply this idea to orbits, because if you think about it, when you think about Kepler's laws, in which he produced these elliptical results for some cases, that's just essentially about adding a direction, force in one direction, a force in another direction, and if you add them all up over time t, you get an elliptical orbit, such as the Earth going around the Sun. Now you can also calculate that in PySpace using this law of the cosines. So let's go on to the next example of this. The next one is the law of the sines, right? So the law of the sines isn't about calculating the distances. The law of the sines in PySpace can be seen as calculating the angles between addition of atoms or pi shells, where the angles are not 90 degrees. So you might know A and B, but you don't know C, and essentially you want to calculate the diameter of the vertex. So you can get you've got the angle, and you've got the length. So let's just do a diagram of that. Here you can see you've A, B, and C. You can see sine A, B, and C, and what you get is the pi shell diameter. Okay, so that is useful also for calculating an orbit, but primarily for the example I'm going to show you now in a second, I'll show you how you can calculate trajectories with the law of the cosines. Alright, so to calculate the general orbit, you need to use both the law of the sines and the law of the cosines in PySpace. That's one way of doing it. Now let's move on to the next part of this. So for example, let's take the example of the Cannonball example, where it's possible to solve by position, velocity, or time. Newton gave us the example, the Cannonball example, where you fire something straight up in the air, and the way it works is that you solve both x and y motions independently of one another. So the formula that you use, it's a very well known formula. I'll just position my mouse here, is S is equal to VT plus 1/2 of AT squared. So in this case you can say I want to know the distance of the cannonball that is fired straight up in the air and at a particular velocity and for a certain acceleration and time. So let's take the example where velocity is 0.1, A is 0.1, and solve for time t in seconds. So in this example here, you can see the results. You can see the way after 1 second you get a distance of 0.15. After 2 seconds it's 0.25, 0.35, and 0.45 after each second. And you can see the distance delta here is 0.1525 and 35 and 45. The actual distance traveled is 0.15, 0.4, 0.75, and 1.2. That's the total distance that one travels. But between each second, these are the deltas. Now that's kind of important because if you sum them up, you get this answer here. And it comes in handy if you want to see how you can calculate that same result using the law of cosines, which is the pi space way of thinking. Let's take a look at how you do that. So the law of the cosines basically, as I say here, it requires slightly new thinking. Basically, what you have is you have a pi shell or an atom going straight up, and what it is it's going straight up with regards to gravity. So those are like two vertices on a triangle, except that the triangle is flat, and the cos of 180 degrees is -1. So this is seen as a flat triangle, right? So you have a pi shell moving straight up with a certain velocity and experiencing an acceleration, a downward acceleration. Normally in this case it's gravity. So, but for the sake of the example, it was 0.1. So it's we just plug that into the formula, and so what we get is this is the s squared. This is the law of the cosines example. So it's s squared is equal to 0.1 squared plus 1/2 of 0.1 squared plus 2 times 0.1 times 1/2 of 0.1. Now in the law of the cosines, the formula is minus 2ab cos theta. So because it's because the cos angle is 180, it's -1, so it's minus 2ab, so you get a plus. So this is the first second. What you're seeing here is the first second of an atom moving straight up under gravity, and we calculate the values and we get 0.15 as the result, right? And then we then take the next second. So this law of the cosines gives a per second value, and then we put in the next second as t is equal to 2. The a is 0.15 from the last calculation, okay, and we get 0.25, and so on. So what we get is 0.15, 0.25, and 0.35, and so on. And if we sum up those times, we get the same results as this over here. So the law of the cosines can be used to calculate the position of an atom moving straight up, because what you do is you use an acceleration which is a fraction of the speed of light, sort of 0.1 of the speed of light, or whatever the value is. So what the Newtonian formula does is it gives us the sum of all the distances in one formula. What the law of the cosines can be done if you apply it to the pi space approach to it is it gives you the per second position in terms of distance of the pi shell. So, and then all you have to do is add them up. So it's a little bit longer. But what it means is, if you're thinking in terms of an orbit, um, what you do is you can calculate per second if you want, and it's quite powerful way to do it. So that's the simplified example when you're going straight up. Now, if you're not going straight up, let's say you're dealing with an example, you want a more general solution to an orbit. The way you do it is as follows. I'm not going to go through the whole detail of it here completely, but basically, the idea is that you have a position 1, you have a position 2, and you have a position 3. So in the case of the example I showed you already, the position 1 would be the law of the cosines, give it straight up, but we're not going exactly straight up. We're also changing angle as well. So what you have is you have a distance from the center of gravity. You have v times t here as this vertex, and then you have the inward vector of 0.5 times at. And you see this triangle here? Those positions can be calculated in terms of the law of the sines and the law of the cosines. Now, if you want to calculate the angle in here, the angle beta, you have vt, you have the angle alpha, and you have 0.5 times at in u. Right? So the high level steps are: from d, vt and theta, calculate s; from s, d and theta, calculate alpha; from alpha, calculate beta; from beta, calculate u; and from beta and u, calculate the relative offset to determine the next orbital position. And then, just like I showed you in the previous example, you just go back to step 1, and the new position for the distance is s is minus 5 at, theta's new is theta minus beta, and v new is u, is the u value. So that's the basic idea in pi space, is that if you want to calculate orbits in pi space, you use the law of the sines and you use the law of the cosines. And the reason why it works is that the other thing you have to do is that the velocities and the accelerations have to be a fraction of the speed of light. Okay, if I get time later, I may do a sort of maybe a Java program or whatever to work through it. Right now I don't have time, but those are the basic ideas. Law of the cosines is the general addition and subtraction of areas of spheres, and the law of the sines is to do with the angles and the vertex sizes. Okay, that's it.